Hello, welcome everyone to this solution of practice assignment 2 of week 2. Pardon me for some disturbances, there's some construction going on near my home. Anyway, we'll start with the first question. Consider an experiment of tossing a fair coin twice. Let x be the number of heads that occurs in the two tosses and y be the number of tails that occurs in the two tosses. Choose the correct statements. Right. So, what are the ranges of x and y? X will take the value 0, 1 or 2, right? And y will take the value 0, 1 and 2. Okay. So let's write down the joint distribution table for it. So x will take 0, 1 and 2 and y will take 0, 1 and 2. Okay. So what happens when x value is 0? X value is 0 indicates that in the two tosses there is no heads. It means that we should only have two tails, right? What is the probability of getting two tails? That is 1 by 2 into 1 by 2, that is 1 by 4. Now what about these two outcomes? These two will be 0, right? And what about whenever the x takes value 1, it means that in the two tosses we have only one head. It means that the other toss will be a tail. So this possibility is 0 and this possibility is also 0. And what about this guy? This guy we can either get head in the first toss or in the second toss, right? So we'll get 1 by 2 into 1 by 2. Let's say the two outcomes for this guy is tail head or head tail. What is the probability of getting this? 1 by 2 into 1 by 2, that is 1 by 4. Again the same thing here. So what is the probability of this outcome? That will be 1 by 2 plus 1 by 2, that is 1 by 4, 1 by 2. Right, so what is this guy? What happens here? If x is 2, that means in the two tosses we have heads, right? What is the probability of getting that? That is 1 by 4. If we have two heads in the two tosses, can we get any value for y? No, right? So these guys will be zeros. Now, what are the questions they are asking us? They are asking, in the first options, they are asking us to check the dependency, right? So what happens to the dependency here? How to check the dependency? Easy, that is, we have, let's say fx of, let's take any one, 0, let's go with 0. Fx of 0 is nothing but, we have to sum this particular column, right? So what do we get? 0 plus 0 plus 1 by 4 is 1 by 4. Then what happens for fy of 0? So we have to sum this particular row, that is 0 plus 0 plus 1 by 4, that is 1 by 4. Now what is fxy of 0 comma 0? Now what is that? That is this particular guy, and that is 0. So which is not equal to fx of 0 into fy of 0. Therefore we can say that x and y are dependent random variables. So now what is fxy of 1 comma 1? Fxy of 1 comma 1 is 1 by 2. Yes, that is true. Now what is fy given x equal to 0 of 1 is equal to 1 by 4? How can we check that? Just write down, we can write this expression as fxy of x is 0, y is 1 divided by, what is the condition? Fx of 0, right? What is this value? That is x is 0 and y is 1, that is 0 again. And what about the denominator? Fx of 0. Fx of 0 is 1 by 4. Anything divided by 0 is again 0. Now they have given that as 1 by 4, which is wrong. Now moving on to the next question. Two paired dice are thrown simultaneously. Let x be the outcome on the first die and y be the sum of the outcomes on both the dice. Find the value p of y minus x greater than or equal to 6. Okay. Now what is the range of x? The range of x is 1, 2, 3 and so on up to 6, right? So what is the range of y? Range of y will be the sum of the outcomes on the both die. Okay, so can we get 1 here? No, right? So the least value is 1 in the one die. The other die will have any value greater than or equal to 1. So it will be starting with 2, and what is the max value that we can get in y? That is 12, which can be 6 and 6 in the outcomes of the two die, right? Okay, now what about this guy, y minus x? What is the range of this? Let's say, can we get 2 minus 1? Yes, for the outcome 1 comma 1, we'll get the sum as 2, and we'll get, let's say, y minus x as, let's say this is x and y, and this is, sorry, this is x, and this is the second trial. We do not have any random variable given for this, and this is y, which is the sum of this and this, and this is, let's say, y minus x, and that is 1. So we can get 1 here. And what about 2? Yes, obviously we can get 2, 3, 4, we can get 6. Yes, we can also get 6, right? Now what about 7? Can we get 7? Check. Let's say, where, let's say if we have 7 here, okay, so we have to get, let's say, 8 and 1 here. So this is not a possible scenario. Let's go for, let's say, 9. What are the different possible way that we can get, let's say, 9 here? Okay, we can have 5 4 or 4 5, 6 3 or 3 6. Okay, is there any other cases? Yeah, that's it. So for any of this possible way, we cannot have 7 or any number greater than 6 here, right? So what is the value here? 9 minus 5 is 4, and 9 minus 4 is 5, 9 minus 6 is 3, and 9 minus 3 is 6. As we can see that we will not exceed the value 6 in the range of y minus x. Okay, I hope that is clear for all, and let me just rub this off. Alright, now what they have asked us to find out, they have asked us to find out the probability of y minus x greater than or equal to 6. So that can be written as probability of y minus x is equal to 6 plus probability of y minus x greater than 6. As we just observed that this value is 0, right? So what is this value? We have 6 different elements, and this is obviously, since they have given a fair die, this is uniform distribution. And what is the probability of getting 6 here? That is 1 by 6. Okay, next question. Let x and y denote the number of cars and bikes reaching a street corner during a certain 15-minute time period respectively. Joint distribution of x and y is given as fxy of x minus y. Fxy of x comma y is equal to 9 by 16 divided by x to the power of 4 to the power of x plus y. And they have asked us to find out the marginal PMF of x. So how do we find out marginal PMF of x? That is, fx of x is equal to sigma y is equal to 0 to infinity of fxy of x comma y. Now what is this? I'll just simply write y here, sigma y of 9 by 16 into 4 to the power of x plus y. And now I'll take all the new numbers outside, that is 9 by 16 into, and I'll also take x outside, that is 4 to the power of x. Now what is remaining? Sigma y of 4 to the power of y. Now what is this sigma y of 4 to the power y? Now that is nothing but, I'll just keep on adding the values from 0. What is 4 to the power of 0? That is 1, plus 4 to the power of 1, that is 4, plus 4 to the power 2, that is 4 square, and so on, right? So sorry, this is not 4 to the power of y, this is 1 by 4 to the power y. So this is in the denominator, all these are in the denominator. Okay, so what is this value? So this is nothing but geometric progression, a sum of which is 1 divided by 1 minus 1 by 4, and that is nothing but 1 divided by 3 by 4, which is nothing but 4 by 3. And I'll substitute this back here, which will get fx of x is equal to 9 by 16, 4 to the power x into 4 by 3. And now I can cancel this, which will give me 3 by 4, 4 to the power of x, which can be written as 3 by 4 to the power of x plus 1. Now, what is the second question? Second question, they have asked us to find out, they have asked us to find the dependency, right? So similarly, using the same type of derivation, instead of summing over x, I'll summing over y, I'll sum over x, which will yield me fy of y, which will be equal to 3 by 4 to the power of y plus 1, right? So how to find out the dependency? I'll just multiply these two, which is fx of x into fy of y, which is nothing but 3 divided by, I'll just write here, 3 divided by 4 to the power of x plus 1 into 3 divided by 4 to the power of y plus 1. So which is nothing but 3 into 3 is 9, and now we have 4 into 4 to the power of x into 4 into 4 to the power of y into 4. Now, which can be written as 9 divided by 16 into 4 to the power of x plus y, and which is nothing but fxy of x comma y. So we can say that these two x and y are independent random variables. Okay, question 4. We have 4 independent and identically distributed Poisson random variable with mu value with lambda value is 4 for all the variables. Find the probability that exactly one of the xi equals to 0 and exactly one of the xi is equal to 1. So since we have 4 random variables, they have not specifically mentioned that which of the random variable is 0 and 1. I'll just assume that x1 is equal to 1 and x1 is equal to 0 and x2 is equal to 1. And what about the other two, which these are not equal to 0, 1, right? x4 is not equal to 0, 1. So I'll have to find out the probability of this guy. So this is not the only possible way, right? So I can get x3 is equal to 1 and x4 is equal to 0 and so on and so forth, right? I'll just calculate for 1 and then just multiply with all the different possible ways that this can achieve. So what can happen here, since they have mentioned that this is independent, I can write this as probability of xi is equal to 1 into probability of x2 is equal to 1, sorry, x1 is equal to 0 and x2 is equal to 1, probability of x3 not equal to 0 and 1, and probability of x4 not equal to 0 and 1. Okay, so now I'll just find out this individually. What about p of x1 is equal to 0 is nothing but e to the power of minus 4 into 4 to the power of 0 divided by 0 factorial, which is nothing but e to the power minus 4. And what about probability of x2 is equal to 1, which is nothing but e to the power of minus 4 into 4 to the power of 1 divided by 1 factorial, which is nothing but 4 e to the power minus 4. And now what is probability of, let's say I'll just randomly take x, which is not equal to 0, 1, which is nothing but 1 minus probability of x is equal to 1 into probability of, sorry, plus probability of x is equal to 1, right? So this is nothing but 1 minus e to the power of minus 4, we just found out here, plus 4 e to the power of minus 4, which is nothing but 1 minus 5 e to the power minus 4. And now I'll substitute all these values back in this particular equation, and now I'll get let's say I'll just mention this as, let's say, any random e. I'll have a is equal to e to the power of minus 4 into 4 e to the power minus 4 into 1 minus 5 e to the power of minus 4 whole square. Now, which is nothing but 4 e to the power of minus 8 into 1 minus 5 e to the power of minus 4 the whole square. Now, how many ways these can be arranged, right? So, which is nothing but 4p2. Okay, so 4p2 is nothing but 4 into 3, that is equal to 12. So this whatever that they have asked us to find out, that is one value should be equal to 1 and one other value should be equal to 0, will occur in 12 possible ways. So the probability that they've asked us to find out will be equal to 12 into 4 e to the power of minus 8 1 minus 5 e to the power of minus 4 the whole square, which is nothing but the last option. Okay, moving on to the fifth question. A person tosses a fair coin until it shows a head and rolls a fair die until it shows the number 6. Assume that tossing the coin is independent of rolling the die. What is the probability that number of tosses to get the first head is equal to the number of rolls to get the first 6? Okay, as we can easily understand that these two random variables are geometric in nature, right? So the first random variable, which is number of tosses. Okay, so number of tosses, and that is geometric. What is the probability of getting a head? That is 1 by 2. Now what about the second random variable, that is y? It is nothing but the number of die rolls. Okay, and now what is this number of die rolls until we get the number 6? Okay, what is this? This is nothing but geometric of 1 by 6. Right, now what have they asked us to find out? They have asked us to find out the probability that the number of tosses to get the first head is equal to the number of rows to get the first 6, which is nothing but probability of x equal to y, right? So which is nothing but, which we can get in probability of x equal to 1 and y equal to 1, which we can get in the first try itself, plus either we can get that in the second try, and so on and so forth up to infinity, right? So which is equal to summation of x comma y equal to 1. Remember that the geometric random variable starts from 1 to infinity of p of x equal to I comma y equal to I, right? So since these two are independent, right, so we can write this as summation of right, there's no need to actually split up these two, probability of x equal to I and probability of y equal to I. So this is x comma y is equal to 1 to infinity. Okay, so which is nothing but summation. Now we have to convert, we'll just apply the formula for this. Instead of x and y, so now summation will be from I to y 1 to infinity, which is nothing but 1 by 2 to the power of I into 5 by 6 to the power of I minus 1 into 1 by 6, right? So which is nothing but, and I'll make the powers of these two terms as equal. So what will I do? I'll just take out 1 by 2 outside. Okay, so which is nothing but 1 by 2 and 1 by 6 outside, which I'll have 1 by 12 summation of over I, which is nothing but 1 by 2 into 5 by 6 whole to the power of I minus 1. So which is equal to 1 by 12 summation over I, which is 5 by 12 whole to the power of I minus 1. Okay, so now let me expand this, which is nothing but 1 by 12 is outside, and now I starts from 1, right? 1 minus 1 is 0, which is nothing but 1, plus 5 by 12 plus 5 by 12 the whole square, and so on and so forth till infinity. Now what is the summation of that particular geometric series? That is 1 by 12 into 1 over 1 minus 5 by 12, and which is nothing but 1 over 12 into 1 by 7 by 12, and which is nothing but, and this 12 and this 12 will be cancelled, so we'll have 1 by 7 as the answer. Now next question, question 6. Let x and y be IID geometric P where P belongs to 0 and 1 is a constant. Find the value of probability of x equal to 6 given that x plus y is equal to 10. Write your answer correct to 2 decimal places. Okay, so now the given condition random variable conditional probability is nothing but probability of x is equal to 6 comma x plus y is equal to 10 whole divided by whatever the condition should be in the denominator, that is probability of x plus y is equal to 10. And now so we know that x plus y is equal to 10, and they have also asked that x is 6, so what should be the value of y? Y should be is equal to 10 minus 6, which is nothing but 4. So I'll just write this in terms of y, which is nothing but x equal to 6 and y equal to 4 whole divided by probability of x plus y is equal to 10. Remember that we cannot do this over here. Why? Because we do not know the value of x here. So which is nothing but, since they have mentioned that this is an IID, we can split up these two, x equal to 6 into probability y is equal to 4 whole divided by probability of x plus y is equal to 10. So now we have to calculate probability of x plus y is equal to 10 separately, and then I'll substitute this back here. Alright, so this is nothing but I'll have to sum over all the different possible values over x and y. I'll just write this as probability of, summation of I from 1 to 9. I'll just say how did we get this 9. P of x equal to I comma y is equal to 10 minus I. Now just look into this. What if we have 10 here, right? So if we have 10 here, the x itself will take the value 10, but y cannot take the value 0, right? So because the geometric random variable starts with 1, right? Hope that is fine. So if we have any x plus y problem, we have to take whatever the sum minus 1, okay? And now that should be equal to sigma of over I to 9 probability of x equal to I into probability of y is equal to 10 minus I. So hope this is okay because of IID. And now I'll just apply the formula sigma over I, that is equal to 1 minus p whole to the power of I minus 1 into p into 1 minus p whole to the power of 10 minus I minus 1 into p. Now that should be equal to sigma of I p square into 1 minus p whole to the power of I minus 1 plus 9 minus I. And now here I will be cancelled. What is remaining? Sigma of I p square into 1 minus p whole to the power of 8. And now since there is no I term involved here, so I'll just have to sum this particular term 9 times, right? So which is nothing but 9 p square of 1 minus p whole to the power of 8. So this is the value which will go to the denominator of this particular fraction. So now what have they asked? Probability of x equal to 6 given that x plus y is equal to 10 is nothing but what is there in the numerator, that is p into 1 minus p whole to the power of 6 minus 1, that is 5 into p into 1 minus p whole to the power of 4 minus 1, that is 3 whole divided by 9 p square 1 minus p whole to the power of 8. Here p square and p square will be cancelled. The same basis we can add up the indexes, that is 5 plus 3 is 8, 1 minus p whole to the power of 8 also will cancel. So what is remaining, that is 1 by 9. Again, next question. Two dice are rolled simultaneously. Let x denote the greatest outcome. If the both outcomes are same, then the x will take that outcome, and y denotes the lowest outcome. If the both outcomes are same, then y will take that outcome. Choose the correct option. Okay, so they have asked us to find out whether these are uniformly distributed or whether they are independent, and they have also asked us to find out the joint distribution of x and y. Now we'll start with the ranges of x and y. I'll just write it here. X is greater and y is lower. Okay, what is the range of x? X can take the all values from 1 to 6, right? What about y? Y will also take the values from 1 to 6. Right, so if x, if it is lesser than y, so if we write a if we write a table here, let's say y and x will take 0, sorry, 1 2 3 4 5 and 6, and here 1 2 3 4 5 and 6. Okay, so here if x is less than y for all the, if they have the diagonal here, for all the lower triangular matrix here, x is lesser than y, right? So what will happen for this probability here? So it means that, can we get x less than y? Because x is greater value and y is lower value, in no conditions we'll get x is lesser than y. So fxy of x comma y will be equal to 0. So we can say for all of this we'll have 0. Right, so now, so if x is equal to y, so then what will happen? It means that both the lower and the upper cases are equal. It means that in the both two dices we'll get the same number. What is the probability of getting that? Let's say 1 comma 1 or 2 comma 2 or 3 comma 3, and all of that probability is 1 by 6 into 1 by 6, which is nothing but 1 by 36. So all the diagonal elements of this particular table will be 1 by 36. So now, what if x is greater than y? What will be the probability for that? That is, we can get, let's say for one particular example, let's say 2 comma 1 for this particular element. I can get 2 comma 1 as the outcome or 1 comma 2 as the outcome. For these both conditions, x will be equal to 2 and y will be equal to 1. So what are the possible ways of getting that? That is 1 by 36 plus 1 by 36, which is nothing but 2 by 36. So all this will be 2 by 36, right? So now what about x? Is it uniformly distributed? So how do we find out whether the x is uniformly distributed or not? It means that, well, if the x is uniformly distributed, fx of 1, fx of 2, fx of 3 and all the values taken by the x, the probability of that will be same. It means that fx of any I, let's say, better I'll just take one of the example, fx of 1. What is that equal to? That is equal to sum of this particular column, that is 1 by 36. And what is fx of 2? Fx of 2 is nothing but 3 by 36, right? So obviously this fx is not uniform. Now what about y? Fy of, let's say, I'll again go with 1. So what will happen here? Fy of 1 is the sum of this particular row, right? So that is 1 plus 2 3, 3 plus 2 5, 7 9 11, that is 11 by 36. What about fy of 2? Fy of 2 is nothing but 1 plus 2 3, 5, 7 and 9. That is 9 by 36. So obviously this is y is also not uniform. So what about x and y? Are they independent? Let's say we have these two values, right? So let's find out fx of 1 into fy of 1, which is nothing but 11 by 36 square. Now what is fxy of 1 comma 1, which is nothing but 1 by 36. Obviously these two values are not equal, and hence x and y are not independent. So what about x and y? This is the joint distribution of x and y. Is it uniform? If this table is uniform, all the values inside this table has to be the same, right? So obviously we have 0, 1 by 36 and 2 by 36, three kind of values present in this table. Obviously this is not a uniform distribution, right? So the next question, let x and y be IID uniform -1, 0 and 1. Find the value of p of x equal to 0 given that modulus x plus y is equal to 1. Okay, so the given probability is nothing but probability of x equal to 0 comma mod x plus y is equal to 1 whole divided by probability, that is the mod x plus y is equal to 1. So in the numerator they have said that x is equal to 0. So here we can directly substitute x is equal to 0. What will happen here? That is probability of x equal to 0 comma mod y is equal to 1 whole divided by probability of mod x plus y is equal to 1. So because in the denominator we do not know the value of x goes from all the possible values that it can take. So obviously we cannot substitute the value of x here. And now since they have mentioned that as IID, we can split up the numerator, that is probability of x is equal to 0 into probability of mod y is equal to 1 divided by probability of mod x plus y is equal to 1. And now this particular mod I can take it probability of x equal to 0 into probability of, instead of writing mod y, I'll just write probability of y is equal to plus or minus 1, right? So both are the same thing. Here also in the denominator I'll just write in a similar way, x plus y is equal to plus or minus y. Now what are the possible ways that I can get this? That is nothing but probability of x is equal to 0 into probability of y is equal to 1 plus probability of x equal to 0 into probability of y is equal to minus 1 and whole divided by, and now I'll write all the possible values for these two cases, which is probability of x equal to 0 and y is equal to 1 plus probability of x equal to 0 and y is equal to minus 1 plus probability of x equal to 1 and y is equal to 0 plus probability of x equal to minus 1, y is equal to 0, right? So these are the only four cases wherein the sum will be 1 or minus 1, because we have only three sets of values given, so this can be done. So obviously I can again split up the denominators as well, right? So what about the numerators? I'll just skip that part and I'll just simply write what is the probability of getting x is 0. We have three different values, that is 1 by 3. In the numerator this is 1 by 3, and what is the probability of getting y as 1? That is again 1 by 3. 1 by 3 into 1 by 3 is 1 by 9. And what about the next term? Again this is also 1 by 9, right? So all the terms will have the probability as 1 by 9. So what is this? This is again 1 by 9 plus 1 by 9 plus 1 by 9 plus 1 by 9. So which is nothing but 2 by 9 whole divided by 4 by 9. 9 will be cancelled. What is remaining? 2 by 4, which is nothing but 1 by 2. Now question number 9. The joint distribution of x and y is given by fxy of xy is equal to 1 divided by 2 to the power of x plus y, where tx and ty are both 1, 2, 3 and so on up to infinity. Find the probability of max function of x comma y. So now they have asked us to find out the probability of let's say what is the range of this particular guy. Again, this is again 1 2 3 so on to infinity. This will take the same range as x or y. Okay, so I'll just write it here. What is the probability of max of x comma y? It will take a random value, let's say k. Okay, and which is nothing but a probability of x will be equal to k and y will be equal to k plus probability of only x is equal to k and y must be less than k, right? And what is the third possible way? That is x is less than k and y is equal to k, right? Now that will be equal to, and this is nothing but fxy of k comma k. Okay, and now this is equal to sigma of I is equal to 1 to what should have here, this is k minus 1, right? So we should not get y as k, that is k minus 1 of fxy of what is the value of k, value of x here, that is k comma I, plus sigma I is equal to 1 to k minus 1 into fxy of I minus k. And now that is equal to, what is fxy of k comma k? That is 1 divided by 2 to the power of x plus y, that is k plus k, 2k, that is 2 to the power of 2k plus sigma I is equal to 1 to k minus 1 into 1 divided by 2 to the power of k plus I plus sigma of I is equal to 1 to k minus 1 into 1 divided by 2 to the power of k plus I, and now that is equal to 1 divided by 2 to the power of 2k plus, and I'll take 2 to the power of k outside, 1 over 2 to the power of k into summation, and what is remaining, I'll also add the values of, so this is split up into 2 to the power of k into 2 to the power of I, right? So I'll just write down the values for I as 1 to infinity, 1 to k minus 1. So what will I get? If I substitute the value as 1, I'll get 1 by 2, right? So 1 by 2 plus 1 by 4 plus 1 by 6 and so on up to k. I will take the value k minus 1, that is nothing but 1 divided by, sorry, this is not 2 by 1 by 6, this is 1 by 8 and now this will take the value 1 by 2 to the power of k minus 1. Again we'll have the same thing repeated here, 1 over 2 to the power of k into 1 by 2 plus 1 by 4 and so on up to 1 by 2 to the power of k minus 1. Now this will be equal to 1 over 2 to the power of 2k plus, so these are the same thing, I'll add these two terms here, so I'll get 2 divided by 2 to the power of k, and I'll take 1 by 2 as common, so what is remaining now, 1 plus 1 by 2 plus 1 by 4 and so on up to 1 over 2 to the power of k minus 2, right? And now that is equal to 1 over 2 to the power of 2k plus 2 will be cancelled, so we have 1 over 2 to the power of k, and if we add this up using the formula for geometric progression, so we'll have 1 minus 1 by 2 to the power of k minus 1 whole divided by 1 minus 1 minus 1 by 2. Okay, so after simplifying we'll get the answer as 1 over 2 to the power of 2k plus 1 over 2 to the power of k into 2 to the power of k minus 1 minus 1 whole divided by 2 to the power of k minus 2, and which is nothing but 1 over 2 to the power of 2k plus 2 to the power of k minus 1 minus 1 divided by 2 to the power of k minus 2. Now that is the last option, right? So the next question, let x be binomial of 5 comma 1 by 2 and y is binomial 4 comma 1 by 4 be two independent random variables. Find the value of probability of max of x comma y is equal to 1. Okay, so now again the same thing, uh, which is equal to probability of both x and y can be equal to 1, right? So x equal to 1 and y equal to 1 plus probability of x equal to 1 and y is less than 1 plus probability of x is less than 1 comma y is equal to 1. Now here they have specifically given a value for the max x and y. So what is less than 1? What are the different values that a random binomial variable can take less than 1? Binomial starts from 0, right? 0, 1, 2 and so on. So what is less than 1? It is only one value, that is 0. Now I will substitute here probability of x equal to 1 comma y equal to 1 plus probability of x equal to 1 comma y is equal to 0 plus probability of x equal to 0 comma y is equal to 1. So now that is equal to, since they have given these two are independent, I can just split up x equal to 1 into probability of y equal to 1 plus probability of x equal to 1 into probability of y is equal to 0 plus probability of x equal to 0 and probability of y is equal to 1. So now what is this? Using the formula I can say that 5c1 into 1 by 2 to the power of 1 into 1 by 2 to the power of 4 plus, sorry, into what is this? That is 4c1 again, 1 by 4 to the power of 1 into 3 by 4 to the power of 3 plus again 5c1 1 by 2 to the power of 5 into 4c0 into 1 by 4 to the power of 0 into 3 by 4 to the power of 4 plus 5c0 into 1 by 2 to the power of 5 into 4c1 into 1 by 4 into 3 by 4 to the power 3, and now that is equal to 20 into 3 cube divided by 2 to the power of 5 into 4 to the power of 4 plus 5 into 3 to the power 4 divided by 2 to the power of 5 into 4 to the power of 4 plus 4 into 3 cube divided by 2 to the power of 5 into 4 to the power of 4, and which is nothing but 27 divided by 32 into 256 into 39, and that is equal to 0.128. Okay, so thank you for watching. Hope this is helpful for you. Consider like, sharing and subscribing. See you all in the next video.